Start now?
Mm-hmm.
Okay, hello and welcome to my talk on covert communications. Have anyone heard of this before? Yes? Yes? Awesome, awesome. I'm just gonna give like a quick what it is, types of covert communication and some quick examples. Just a really class lecture-ish presentation. This was supposed to be by two people, but it's gonna be 2 minus 1. But if you guys remember, I started with a meme of the day.
Bro, he's in the item shop. No way.
It's Shandy Fortnite. That's all I gotta say.
In the item shop, guy. Yo.
Nothing special, just that guy.
That's a steal.
Again, I thought this was gonna be me and someone else, but if you don't know the information, it's just that's me, and I have a mustache now. That's all. That's all you have to get from this.
Wait, can you show me the beat?
We can't show you the mustache though. This is my other partner. He's not here. Kenny, really cool dude. Does some really physical implants. Or he's trying to do so. But and with drones. That's his information. So let's start. What is covert communications, or I should say covert channels? By definition, it's pretty much a channel where you are exploiting the system to transfer data the way it's not supposed to. So transfer information using non-standard methods, and it's against the design of that system. Again, we'll show you a bunch of examples. And the key part about covert communications is that the traffic, or the way it works, is it blends with the normal traffic, and it's really hard to really tell when there's a covert channel going on. So it's obscure but unnoticed. And because it's going against the system design, it's easily bypassed like the security tools that are meant to secure that specific system. Just more definition, you can see it allows multiple parties to communicate, and again, the traffic and the way it talks to each other is obscure or is unnoticed. And unlike encryption, again, it's obvious, but you need to just pay attention to really find it. This is like a diagram that shows that kind of just explain everything. You can see the legitimate traffic is, let's say, TCP web traffic just goes, but inside of that TCP header, you're doing some modifications where you have your actual data, and that's it blends with the normal traffic. Again, more examples as we go on. And you might be asking, why does this work? Well, first is, as humans, we are as lazy as they come, and we are, as I read, we are stupid. First reason is our eyesight. For example, I have to pay someone so I can see everything. That's very stupid. So you can use that to your advantage. So you can play with lights that we cannot see, so like ultra, what's that thingy? X-rays and all that stuff. Yeah, you can use that as a way to transfer data because we can't see it, but we know it's there. We also have our ears. With this one, you're just playing with the frequency of sound. I don't think exactly know the range of sound we can hear, but you guys know that we have a limit, so you can also play with that part. So when you use those sections that we cannot, as humans, capture, you can use that as a way to convert to move data from one place to another. Okay, and the next is just, again, we are just lazy. If we don't find anything interesting, we just don't care about it. So if you believe that the covert communication is something that again happens like once in a long time, you don't care about it to like create like tools to defend those. So because of our lack of interest, we cannot just use that as good advantage. And also with covert communication, you cannot see it, or it's really hard to detect. So as some people would say, if you can't prove it to me, I do not care about it. So you can also use that to your advantage. And lastly is just you're playing with the system, the way the system is designed. Just doing stuff in a way you're not supposed to. So just being a hacker, I guess. Yep. And again, the big part is you're able to just bypass those security mechanisms that are already that's already in place that and is supposed to defend you. So if you're doing something that is unknown, obviously there's nothing to stop you. So and that's why it works flawlessly. I wrote perception over reality. I don't know, man. Just it sounds cool. It makes me sound philosophical words. Okay. Quick issue about covert communications. It's been used way before our computers and stuff. The first known, that's a quote on the known because I've looked for different references and there's like different known dates. But I'm gonna use this one as an example. The first one I found was using Stego. For the CTF folks know this. Stego can be used as a covert communication. It's in that family. And it's one of the best ways people have used in the past to just transfer data. An example of that is invisible ink. I think people still use this, but it's not often. Another one is putting messages on animals. So if you have the money in your pool, you can use that to just send data, I guess. And the last one, which is a little weird, is just putting messages on your people you have control over. I'm glad we don't do that anymore. So there are different families of covert communications. Oh yeah. So the cycle again, most people should be familiar with this. The other ones is using the network channels, so TCP headers, UDP, HTTPS. There's going to be an example. You use the operating system, so this is like if people who took CSEC 140, there's a lab about alternate streams. That's a form of covert communication channels. Data appending, I don't know what that means, but I know this one, this is text manipulation. It's just playing around with text, so you can say, oh, every 20 words in this letter is the actual message. I think I have a picture that should show that. So again, this is the family, but there are two types of covert channels. There's storage and timing. The storage channels are ones that write the data onto like a storage location. So like in Linux, you write it to a file, you write it to a process, you write it to a memory, whatever. And you have another guy or another receiver that actually knows that same location and reads from there. So this is pretty straightforward. I think we use this every day. When you write your files to your system and you read it, it's not covert communication, but that's a way that you can use that to transfer data. Pretty straightforward. Again, those are some examples that people can use to really transfer data using storage channels. The next one is timing channels. This is just based on timing. You can do it at a consistent time, or you can do it at a different interval so it doesn't look too suspicious. And these ones, I think they're one of the hardest ones to use because they are dependent on the OS. As you can see, you use some CPU to mess with the CPU, resources or memory. And there's also the packet. So for the packet header, it's more like you send the packet like every 2 minutes, or you have like a range. So you let's say you have an array of 1 to 5, you can do that like pick a different number, or like again, it's based on time. It's not writing to the disk or anything. It's just time. When I was writing this, I noticed that I spelled out CPU out, and that just reminds me of when you have to do it. It's based on time. So nice. So now we go to the examples. These are the ones that are being used in the past. The first one, does anyone know this guy? Yes? Awesome. I'm not going to explain a lot about it. Do you want to say something? Make it interactive.
Soviet Boy Scouts, some people this wooden carving of the Great Seal of the United States, the U.S. ambassador for the Soviet Union, and the NSA checked it. They didn't think it had any bugs in it, but then things that were sent in the ambassador's office started to leak, and it turned out they invented a device that was powered by radio waves from a building across the street, and then transmitted even more radio back.
Awesome, thank you.
With that example, I think the part of the human that it's been exploited is the our audio part. So obviously and also I guess our eyes, we cannot see those signals being passed around. So obviously that's being used as an method. And the second one is Stuxnet. You guys should know about Stuxnet, right? Yeah. So this is you think about this. It bypassed air gap. Air gap is obviously when something is not connected to the internet, at least in our field. So the way this was bypassed is just using USB. No fancy stuff, just exploiting people as people. Just drop the flash drive everywhere they go, and just eventually someone will pick it up and just plug it in. And now we've bypassed the air gap. Pretty simple. So this is some of the things we have done and things that could be used. So Discord, we use it all the time. The traffic, you guys don't know what the Discord code is. It's pretty much RCE or C2 on your computer. The reason why I consider this as a covert channel is if you try to look at the traffic, you cannot tell the difference between what I send and an active Discord traffic, because again, I'm just talking to Discord and it's normal. So it makes it really hard to know what's going on. Vishnu, this is on the network level and not kernel level, but like it's a packet sniffer. It listens for those different packets, and to the network adapter, it probably doesn't make sense why I'm pinging this computer like 5 times on port 1, 2, 3, 4, 5. It makes 0 sense. But they just assume that it's just this hacker from this country is doing some port scanning. But the fact that it's not something they would immediately think that that's probably a way to just get a shell. That's bypassing that security mechanisms to prevent stuff like that. Hence, a covert channel. You can use ICMP, so you can mess with the payloads that's sent when you ping a computer. There's a shell that I do not know how to do that, but it's possible. I would like to point out, I took a class in IT. You have the choice, take the covert. You can take the covert communication class if you want to. It's a lot of reading. But at the end, you do have to write like your own form of covert channel. And me and my partner was actually here. We wrote one using Reddit. And we looked into using the different methods. So we're looking into using the upvotes as a way to like use the 1 and 0s. We also looked at the title of a post. So we can make like 5 different posts, random, but like obviously we look at specific characters to be our message. So things like that. You can just look at what's around you and just try to make it work in a way it's not supposed to. Yep. So in the people who have done this research in like actual, like being practical and just as a proof of concept, some of them are just really, really crazy. Examples are this. The first one, GSMem. This is like, Kenny's not here to really explain this, so it's not going to be really good. But the first one is using the CPU to create some kind of signal in memory. I on how that works because it's all of these are all the part of the operating system family of Covert channels. Um, the key part I really want to point out, or the interesting one I want to say, is the picture we have right here, which is the last one, using the temperature as a way to send data. So you have your sender on this machine, and you write it in a way that it changes the temperature of the computer. So like if it gets hot, that's a 1. When it gets cold, it's a 0. And you can just do that over how long you want to just really get the data from your target. And as you can see, this is I think this is too hot and this is cold, so this is 1 and 0. And again, this exploits our eyes because we do not see this. As you can see, it's pretty normal, but there's something working behind the scenes. Pretty cool. So, moving on to the networking part of stuff. This is one of the papers we had to refer back for the communication class, and it's using the TCP IP header. So there's different methods. So this is what the TCP I think part of the TCP IP header is. Some part of these headers are not required, or they're optional. So you can use that to your advantage. The first one is using the IP identifier. I don't exactly know what it means from a networking point of view, but a way you can do that is it accepts a 8-bit character, and so every letter can be converted to a number, and on the receiver side, it just takes that ASCII number, sorry, not ASCII number, it takes a number and gets the equivalent, the ASCII equivalent. I have a link to the PDF, you guys can read it. There's another one using the sequence number, so the beginning, when you do a TCP handshake, the first one you have to initialize a sequence number, so you can also use that number as a way to send your data. So the number would equal an ASCII character, so that's another way. And the last one, using the bounce, it's a little over my head, but like the goal of that, the bounce field, is just being to talk to another computer. So like if you want to talk to computer C, which is over there, I can send it to computer B, and B, using the bounce, would send it to computer C. Again, I have the PDF if you guys really want to know how it works. There's also sample code, so you can even try yourself if you want to. And this was some weird examples that students at RIT have done in that class. The first one is using Super Mario Maker. You guys know what that is, right? Yeah. Essentially, for each item or each block, it's also mapped to an alphabet, and the alphabet has the values and whatever. So, just some crazy stuff. Like, I can't. It makes no sense to me, but it makes sense if you read the paper. And it goes on to use more games. There's the TF2 maps. There's also Run Escape. And they pretty much all use the same mentality. They take, if it's an item-based game, like most of them are, they just take that and map to a message or a number. And that on the receiver side would know, like, in this case, the receiver and the sender needs to know what is what, and they can just decode and encode based on how the communication is going. So, again, I don't. I can send the paper if you guys are interested in any of this once I just listed. And yeah, this is some of the resources. If you want to go deep into how to create your own, there's many ways. There's using the networking stuff, which could be used. Red team idea. That's one. You can do some really weird storage one. So like writing to a file and using the timestamp as a way to send the data, because no one often looks at the timestamp of the file that's being created. So that can be used. I'm just spitting some ideas that just to prove that everything you do right now can, if you just think of a really weird way to use it. So like use the system in a way it's not designed. So it's can be pretty easy, and sometimes they can get really hard depending on how you want to go. If you go physical, or if you try to do a physical covert communication, that's probably going to take a little bit of time, except you know your stuff. But I think most of us here are software guys, so I think we should be able to get this in like a few hours or so. But that's about it. That's all I got for today. Just an intro to what covert channels are and why they're pretty cool. Any questions? Yeehaw, I guess. Number 20, done.
20, 21.
This is 21?
This is